Alright everyone, so it seems a shame to have created such a cool wind effect and not to let it affect the game. So to finish with the wind, what we're going to do is make it affect the way the wizard moves. So effectively we're going to have the wind kind of blow against him, and that's going to slow him down when he tries to move left, speed him up when he tries to move right. So as if when he's running against the wind, he's getting pushed back. So the first thing that I want you to do is I want you to create a new variable. Call it movement distance, and it's just for the wizard. So we're in the wizard code, I forgot to say. And way down in walk, we have this command here that says move 10 steps. Well, instead of 10, we're going to change that to movement distance steps. And we're also going to introduce something that says when I receive start level, set movement distance to 10. So this doesn't change anything right now. This leaves everything as it is. He still moves 10 steps. It's just that we've stored the 10 in this variable movement distance. But now that's going to allow us to kind of play around with this in different circumstances. So the circumstance in question is when there's a gust of wind. So when I receive gust, what we want to do is something like set movement distance to something less than 10 because he's trying to move against the wind, or something more than 10 because he's moving in the same direction as the wind and the wind is pushing him along. So one thing we could do is do it with an if then else. So we could say, look, if he's facing one direction, then reduce his movement distance. But if he's in the other direction, then increase the movement distance. But we're going to do something a little bit more elegant. Since we're dealing with numbers, we can make everything a bit more simple using mathematics. So let's build a function that determines how much we want to adjust the movement. So grab a plus, and the basic movement distance is 10, but we're going to add something. And this value is going to be positive if he's moving to the right, because the wind's blowing him faster, and it's going to be negative, so you're adding a negative, which is the same as taking away, if he's trying to move to the left, in which case the wind is pushing against him and reducing his movement. So how big is the effect that we want? Well, we want basically something that's proportional to the gust strength. So the stronger the wind, the more it pushes the wizard around. But gust strength is from 0 to 20,000, which is way off scale. So we're going to reduce that by dividing it. Now, if we divided it by 2,000, it would bring it down to 1 to 10, which is about the right range. But I want it to just be a little bit stronger, so I'm actually going to reduce it by less than that. So I want to put this in here, except that I want it to be plus when he's facing one way and minus when he's facing the other. So I just have to fix that as well. So to get the effect that I want, I'm going to use a trick that we've used before. So remember that direction is negative if it's over here. So you can see the number underneath the dial, these are all negatives. And positive if it's over here. So we just need to find out whether his direction is positive or negative. If it's positive, then he's facing to the right and the wind is going to add to his movement. If it's negative, then he's facing to the left and the wind is going to subtract from his movement. Instead of using the whole directional number, I want to find something that reduces it down to a simple switch that is 1 when the direction number is positive and -1 when it's not. And so that means it's 1 when the wizard's facing right, which means it's 1 when his back is to the wind, and it's -1 when the wizard faces left, which means it's -1 when he's facing up to the wind. So I just need to find the value of this. So to find out whether something's positive or negative, this is what we do. You grab a divide and you grab an absolute value, and then you put that in one of the slots. And then you take the thing that you're trying to decide is positive or negative and you drop it in the other 2 slots. So in this case, we want to know whether his direction is positive or negative. So we just drop it in here. And so you can see what this does, right? Suppose his direction is 50. What's the absolute value of 50? Well, it's just 50. What's 50 divided by 50? That's 1. And the same for any positive number. If it's 75, the absolute value of 75 is 75. 75 divided by 75 is 1. So it's always going to be 1 if direction is positive. But if direction is negative, okay, so now you have, let's say it's minus 10. Okay, well, what's the absolute value of minus 10? It's 10. What's 10 divided by minus 10? Minus 1. And so whenever this is negative, it's going to return minus 1. So this is the function we've been looking for. So now grab a multiplier and put these two together. So this whole thing is going to be gust strength divided by 1000 if direction is positive, and it's going to be minus gust strength divided by 1000 if direction is negative. So if we now drop that in here, it's going to add to his movement when direction is positive, i.e. when he's facing to the right, and it's going to reduce his movement when direction is negative, i.e. he's moving to the left. Now the only thing I need to add to this is I don't want this to just happen as a one-off, like instantaneous effect that you hardly notice. I need the wind to keep pushing on him until the wind fades off. So grab control and, not repeat, but repeat until. Grab a less than, and gust strength is less than 1. So this is going to keep pushing against him or helping him until the gust strength is less than 1. Let's try that out. So you can see when the wind is strong, it's hard for him to move against it. But it's very easy for him to... It's very easy. It actually moves him faster when he's moving with the wind. Now I'm a little bit worried about it blowing him way off screen. So we'll fix that in the next video. I'll see you there.